Hello, and welcome to my Pre-Algebra review series. This video covers Chapter 8, Section 8, entitled Graphing Linear Inequalities. By the end of this video, you'll have a better understanding of graphing linear inequalities and graphing systems of linear inequalities. Please leave a like if you find this video to be helpful. Give your classmates a heads up too. It will more than likely help them, and it will certainly help this channel to be seen by more students. If you would like me to cover any of these topics in greater detail, please leave a comment in the comment section below. I read them and do my best to answer each as time permits. Please subscribe to my channel and ring the bell icon to be notified every time I release a new video. Thank you. Let's look at some inequalities. Okay, Objective 1, Graphing Linear Inequalities. Let's talk about them. If you replace the equal sign in a linear function with a greater than or less than or greater than or equal or less than or equal sign, the result is a linear inequality. The graph of a linear inequality is a region of the coordinate plane bound by the line. Every point within the region is a solution of the inequality. The line itself may or may not be included in that solution, indicated by the bounded region. The determining factor is the inequality sign, and the less than and the greater than symbols both exclude the line from the solutions. And the greater than or equal to and the less than or equal to symbols include the line as part of the solution. Graphs of solution sets that include the line in the solution, less than or equal and greater than or equal, are generally depicted with a solid line, whereas the solutions that do not include the graph line, less than or equal to, are generally depicted with a dashed line. That indicates to you that don't include the line. If it's dashed, don't include it as part of the solution. Okay? Example 1, Graphing a Linear Inequality. So we have a couple of samples here, and just to kind of show you the difference in them. First one, A in A, says y is less than or equal to x plus 2. So what that's saying to us, if you just think about it, it's saying that y, the value you're going to select for y, that's the vertical, any vertical position on the chart, is less than or equal to whatever value you select for x plus 2. So if I select the value of minus 2 for x, and you add 2 to it, then the y is going to be 0 or less. Okay? And also, let's go to B then. And that one, it says y is less than minus 2x. Well, there is no plus anything, so whatever x is, you're going to multiply it by minus 2, and your y value has to be less than that. So what we do is we go, like going back to A, we graph the line. You treat this as if it's a linear equation, and y equals x plus 2, and you calculate what the values are using the linear equation, and you plot it. In our case, let's start with the way we would a normal equation. We'll set x equal to 0, and we'll see that the y-intercept is at 2. So if we start at 0 right here, 0 is x, right there, and we say y is equal to x plus 2, then we go up here 2, and lo and behold, there it is. We've found the y-intercept on that line. So no matter what you select for x, if I select 1 for x, it's 1 plus 2 at this point. Here's 1 plus 2 is 3. So it's finding the dots along this line. Well, we know how that works because we understand linear equations. But this inequality says that y is less than or equal to. So any y down here in this region, any y down in this region down in here is valid as a solution to this problem. And if we go over to the other side, well, let me go ahead and see if I can, let's see, can I do a magic marker here? Well, let's put in some colors. I'll put in this guy here. So this is all the solution. All of this, any and all of this, is a solution to that inequality. If we go to the other side, I'll use yeah, green for this when I play with the line. I did the same thing. I took and I replaced the inequality symbol with an equal sign. Right here, I made that an equal sign. And I said, okay, y is equal to minus 2x. So I set x to 0, and I know that y is now 0. So if I look here on the graph, I see that when x is 0, y is 0. So I found the y-intercept. And now the slope is negative 2. So what does that mean? It means every time I go down 2, I go over 1. Well, lo and behold, 1, 2 down, over 1. There it is. 1, 2 down, from here, 1, 2 down, over 1. There it is. So I plot the line. But this one says that it's less than. It doesn't say equal to. It doesn't have the equal sign beneath it. So as you see, it's a dashed line. We've got this dashed line coming down here. So that's saying do not include. This line is the bounding property of this equation. However, the line itself isn't included in the solution. So when we found this one is x equals 0, we said y is less than 0. That means that anything up to 0, but not including the 0. So, and if we take and we try to show the bounded region, the entire bounded region, it says any y that's less than negative 2 times x is part of this solution. So that means that all of this, anywhere that y is less than that value right there, and it's right here in this case, or it's right here at y is, and when you're negative 1, y is 2 positive 2, anything below that is the solution. Just like over on the other side, anything below the line over here, but including the line. On this one, we include the line all the way up to and include the line is part of the solution. Okay? Okay, for example, 1 under check your understanding, we have 3 graphs here. They want us to graph each inequality in its own coordinate plane. So that's what we've done. We've put these inequalities on their own coordinate plane. What we've done a little ahead of time, as we've been doing all along in these reviews, is I oftentimes will put the line in ahead of time so it's already drawn out for you. Save us a little bit of time. We don't have to draw the line. And to be honest with you, I have a hard time drawing the lines. But, so the first one here says y is greater than 3x minus 1. Well, the first thing we want to do is we want to find the y-intercept. If I say that x is 0, right here, if I set x equal to 0, then the 3x goes to 0, and the answer is minus 1. And if you look down here closely, if I say x is 0, right here, right there, is about 1. These are 5. Each line is 5. So 1 is right down here pretty close. So you see we found the y-intercept. And now it's saying that, and it's not including, also notice that there's no bar underneath here to say greater than or equal. So it just says greater than, okay? And doing that, now I've got I can plot the line because I know the slope. The slope is 3, which means over 1, up 3, over 1, up 3. So if you go over 1 here, this is 5, so 3 is about in the middle here. So you can see right in about here is where that crosses that line, and that goes all the way. So that forms our line. That forms our line right here, up through here. And as you see, it's a dashed line. So what does that mean? It says y is greater than. So it's easy to pick. What are the solutions? Well, if I pick any point on the line, there's a y value. Right here, the y value is minus 1. Well, they're saying that it's greater than minus 1. So I say then that all of this above the line is this part of the solution, but not including the line. The line itself is not included. Okay? If I choose, I think I'm going to try something different here. Let's try this one. Wait till I see. In this one, it says y is greater than minus x plus 3. Well, I set x to 0, and I come up with the minus x as 0, I get a plus 3. So if I look for 0 down here, here's 0, And lo and behold, there's a line right there at +3, our y-intercept. We know the slope is -1, so that means it goes over 1, down 1, over 1, down 1, to the right, down, to the right 1, down 1. That's what a -1, -1 over 1. Everything moves by 1. So these are counting up by 1 here and up by 1 here. So if I went down, it's negative, I go down 1 and over 1. As you see, the lines on that go from here, down 1, over 1. And there's our line right through here. Okay, you see it. I don't want to cover up the dashed line. So it's greater than. Y is greater than this. So we're going to select that anything that's in here is greater. This is the solution up in here. Y is greater than anything on that line, and we don't include the line. Here's another one. Y is less than 2x minus 4. So again, we're going to do 2x and zero it out with put x to 0. We have minus 4. So if I said x equal to 0, right here, I'm at minus 4 on our problem C. If I go, and it's a 2 is the slope. So that means if I go over 1, I have to go up 2. So if I go over 1, here's 1 over, I go up 1, 2, right there. Let's see. Oh, this is why I went all. These are 2. Excuse me. These are 2 each. So if I go over 1 from here, I go up to here. If I go over 1 from here, I go up to here. So that's the. I misjudged on the size of the spacing here. Okay, and so what section do I include? What is the included section and the not included section? Well, we know right off the bat that the included section is not the line, because the line is dashed. If the line was solid, this would be a less than or equal to, and we would be including the line. But right now, the only solution to this inequality is every point, every y value along any x value that is below the line, because it says y is less than the line. So your y value has to be less than the line. So in doing that, we can include everything in here, everything up to the line, but not including the line. Okay? Okay, let's look at example 2. It's a real-world problem. So apricots cost $3 a pound, and tomatoes cost $1 a pound. You plan to spend no more than $10. No more means that you can spend up to $10, including $10, but no more than $10. So that should trigger what kind of an inequality this is. So we're going to let x equal the number of pounds of apricots, and we're going to let y equal the number of pounds of tomatoes. And so our inequality, we're going to write, is going to be 3 times x, $3 a pound for x, which are the apricots, plus 1y, $1 pound is going to be $1 a pound, because we found out that up here at the top, it's $1 per pound, right up here. Let's see. Right up here, $1 a pound, right there. Okay, so it's $1 a pound for y's, and the inequality is 3 times the number of apricots plus 1 times the number of tomatoes is less than or equal to $10, because we can spend up to $10, including $10, but no more. So you write the inequality. So we're going to write the inequality, the equation of the boundary line, in the form of y equals mx plus b. We have to solve the line that determines how many and what you can and cannot buy. So we're going to write the inequality. We're going to solve the inequality for y. So what we've done is we have 3x plus y is less than or equal to 10. So what we're going to do is we're going to subtract 3x from both sides. So we're going to subtract 3x from this side and 3x from this side, right? 3x from that side. And then we're going to end up with y is less than minus 3x. Here's the minus 3x plus 10. So now that we have the solved inequality for y, we can now change the inequality for the equal sign to make it a linear equation and draw our line. And what does this say? It says first, go ahead and set x equal to 0, and we'll get our y-intercept. And if you look over here in our chart, if we set x equal to 0, you're going to see that the y-intercept hits right here at 10. Right up to 10. I should have made that line a little bit longer. However, right there at 10. And then it says, what is the slope? Well, the slope is a negative slope. Oh, look at this. The line is going down. It's negative. And it's minus 3. So that means that for every 1 we go to the right, we're going to go down 3. So these are 2's in all cases. We're going to go like, so if I do 6, I'll be an even number, right? So if I go down 6 and over 2, I'll be right here, which is the same as going down 3 and over 1. I just cheated to find the grid mark on the graph. That way I multiply this by 2 in order to jump ahead because these are by 2. Okay? Anyways, so here's our slope. So the slope is going down at a negative 3. So is the line included in our equation and in our inequality? Yes, because it's less than or equal to. So what does that tell us? It says that in the solution, we're graphing y equals minus 3x plus 10. But for the inequality, what are solutions? How many tomatoes and how many apricots can I buy are all saved for right here. And again, what does it say? It says y is less than the equation of the line. Here's the line. Here are all the values of y associated with the line. And our solution to this inequality is everything below the line. Okay? Everything below the line is included. And I go up including the line. I'm trying to draw up there and include it. And everything including the line is part of this equation. So there's the solution to this. Okay, here's another one of the same type of problem we just had. For example 2 under check your understanding. So it says, adult tickets for the school play cost $4. Children's tickets cost $2. Your goal is to sell at least $30 worth of tickets. So let's let X be the number of children's tickets we're going to sell, and Y be the number of adult tickets we're going to sell. And now we're going to graph the linear inequality to show how many of each type of tickets you must sell to reach your goal of, what did we find it up here, of $30. We want to reach a goal of $30. So let's write the inequality. We've set X be the adult tickets, and we know that the adult tickets cost $4. So we're going to, the adult tickets, the X is the children's tickets, excuse me. Y is the adult. Y is the number of adult tickets. So we're going to go down here. We're going to see that 4 times Y, right here, $4 per every Y ticket right there. And the children's tickets, $2 for each children's ticket or child's ticket. And here X is the number of children's tickets you have to sell. So there is the 2 times the X plus 4 times the Y, and you have to sell, or your goal is to reach your goal. So reaching your goal means that you want to get $30, so you're going to include $30 in your goal, and anything above $30 is in your goal. So that means that what you want is greater than or equal to $30. Because you want to sell certainly $100 worth of tickets. So you want your goals to be greater than 30, but you also will accept the very minimum of 30. So now we have our inequality. Let's solve it. So we're going to, in this case, we're going to subtract or add minus 2x to each side. We get that going on here. Then we simplify it. We get rid of the 2x on the left-hand side, and it's on now on the right-hand side. So we have 4y is greater than or equal to 30 minus 2x. So that's kind of the way you think about it, right? The number of adult tickets is going to be equal to $30 minus whatever I get for the children's tickets. Okay? So now I have to get rid of the 4 in the 4y part. We have to get the y by itself. So we're going to multiply by the reciprocal of 4, which is 1 over 4. And so that means we're going to divide by 4 on this side and divide by 4 of each term on the other side. Everything gets divided by 4. And when you do that, we'll have y greater than or equal to 30 divided by 4 is 7.5, $7.50. And we're going to subtract 1/2. So 2 over 4 is 1/2 x. And so we're subtracting 1/2 x. That's our inequality. Then we convert that to a linear equation by converting the inequality sign to an equal sign, and we draw the line. So how do we do that? We set the x equal to 0. So that means the negative 1/2 goes away, and what's remaining is 7.5. So if we look here, we go x is 0 on our chart. X is 0 right down there. And we go up to where? Right here at 7.5. Here's 7. Here's 8. Here's 8. Here's 7. We're right in the middle at 7.5. So we've set our starting point. And our slope is negative 1/2. So every 1 we go down, we go over 2. Down 1, over 2 to the right. Down 1, over 2 to the right. And as you see it, we have a negative slope, and you see our line is going down. Okay? So let's go ahead and see if we can take a look at, well, let's see. First I'll draw this out. We're going to go down 1 and over 2. Well, down, we're at 7.5. We have to go to 6.5. We go to 6.5 right there. And then we have to go, this is 5. Down 5, 10, 15, 20. So 2 is right about here. And if I go up there, it's right about there. That's the spot right there. And then we go down 1/2 and we go over 2. Now we're should be over by the 4, somewhere in here. And anyways, if you take that down, you get this line down through here. And we know that it's a solid line because it's greater than or equal to. So we have a solid line. And what are the solutions to this equation? Well, the solutions, I'm going to get a yellow marker here. The solutions are where it says here, it tells you y is greater than or equal to whatever the line is. This is the line right here. Here's the line. Here's the line. Y is greater than that. So wherever I pick the line, I can pick a y greater than the line. Down here on the line, I can pick a y up higher. Here's the y for the line. I can pick the y here. So it says everything above the line is included in our solution, including the line. So remember, you look at this, are you above or below, greater than or less than? If it's greater than, you go above the line. If it's less than, you go below the line. Those are all your solutions. Okay, objective 2, graphing systems of linear equations. So linear inequalities, excuse me. So what we're going to do is we're going to see 2 lines on the graph because it's a system now. And we're going to try to find the solution to both inequalities at the same time. So this is kind of fun when you look at these. So it says 2 or more linear inequalities form a system of linear inequalities. A solution of a system of linear inequalities is an ordered pair that makes each inequality in the system true. To solve a system, graph the inequalities as if they are lines on one coordinate plane, and then determine from there as to what type of inequality it is, and then what is bounded by the solution. Okay, example 3, solving a system of linear inequalities. solve the system. Y is greater than x, and y is less than or equal to minus x plus 2. Okay, well, I can tell you right now, I've looked at this, and there's a mistake in this slide, but I'm going to pass it over. This should be, because I'm looking at the graph down here, it's greater than or equal to, okay? Because if I look down here, both of these lines are solid, and it says greater than or equal to, so excuse me, there's a little bug in here. So those are the two equations. So step 1 is graph y is greater than or equal to x. So y is greater than or equal to x. Here's right here, the blue line. We're making that the blue line. So is this blue? The blue line. And we'll make the other one an orange. It's an orange line, I guess that is. This line here will be our orange line. So let's go back to blue. And as you see, y is greater than or equal to x. This is the graph of that line right here. If you set x equal to 0, then y is equal to 0. And guess what? There it is right there. Y and x are both equal to 0. So, and it's equal to, so it's a solid line. And remember, when you're drawing these lines go forever, by the way. Okay? And then we're going to graph the other line. I'll change that over to the orange pen. The other line is this one here, and it says y is less than or equal to minus x plus 2. So if I set x equal to 0, y is plus 2. Here's x equal to 0, and y right there is plus 2. And this one has a slope of, this one was a positive 1, the slope on the blue line, which it went up 1 over 1, up 1 over 1. This one is negative x, which means it's going to go down 1 over 1 to the right, down 1 over 1 to the right. And if we look at it, we go down 1 over 1. Bingo. The solution is right there. Also, for the linear the equations is right there. 1, 1 is the solution to both of those equations. Okay? So now that you've got these two lines, what truly is in or included in the bounded areas? Well, we know that y is greater than or equal to x for the blue line. So that means I'm going to go select the blue. Can I get a blue marker here? Everything here, y is greater than or equal to. So all this area out here is all included in for the blue line, including the blue line. And for the orange line, what's included there? All that's included is, it says y is less than or equal to the line. Here's the line. So you pick anywhere that you pick a spot on the line and you go down because y is less than. So everything here. Okay? So that's the solution to the one line, and the blue line is the solution to the other inequality. So what is the solution to the system? You have two lines. The solution is not all of this area that's colored in. The solution, I'm going to change it to red over here, is anywhere where both of them are included. So the solution to this system of inequalities is this area here where it's below the orange line and above the blue line simultaneously. This is the solution. Okay? Okay, example 3, check your understanding. Solve each system by graphing. Well, we're going to go through this and solve these inequalities for y. Oh, they already are. A already has solved for y. So now we just have to graph the two lines that make up this system of inequalities. So we're going to set, in our case here, we're going to set the x equal to 0. And when we do that, we have y is less than or equal to minus 5. So when x is equal to 0, and these are all going to be 1. All these tick marks are going to be 1. 1, 2, 4, 1, 2, 3, 4, 5, 6. It gets a little cluttered if I draw too many. But each one of these are 1. So this one here is 2. You get the picture. Okay, so When x is 0, y is minus 5. X is 0 is right here. 1, 2, 3, 4, 5. Right there. For the first equation, the y-intercept is right here at negative 5. And I'm going to call this the blue equation. And it's a negative slope. So it's actually going to go down. Okay, it's going to go down 2 over 1. Well, I'm going to reverse it and go the other direction so I can head toward the x-axis line. So I'm going to go up 2 and then to the left 1. So that's reversing it. You can go right 1, down 2, or you can go up 2, left. Okay, you can convert it. So I'm going to go up 2 and 1 over. Up 2 and now I'm 2 over. Up 2 and now I'm 3 over. So our line, if I can draw a straight line through here, is along here. Okay, not too bad. I've done a lot worse than that in the past. And so that's that line. And now we have y is less than or equal to 1/2 x. Well, when x is 0, we're going to change the color of this to, let's do an orange. So when x is 0, y is 0. So here's this y-intercept. And so the slope here is 1/2. So we're going to go, that means we're going to go up 1 and to the right 2. Up 1 and to the right 2. Because the x travel distance is 2. So, or we can go backwards. We can go, since we're going up 1 and to the right 2, we can go down 1 and to the left 2. So down 1 to the left 2 is right here. Down 1 to the left 2. 1, 2, 3, 4 is about right there. So that line, I missed the dot. Anyway, so that line, it goes through here. So what are we looking at here? I'm going to go up. Okay. So now it says, here's the two systems. And this one, the blue line is less than or equal to. And what we're going to say is the orange line. I guess we're doing orange here. The orange line is also less than or equal. So that means these lines are solid. I should have mentioned that before. And we want to find out what is in the bounded area. Well, like I said before, also, y is less than whatever the value. This is the value of the line. We're saying any point you pick on the line, the y, you select a y value less than that. It says less than. So on the blue line, I'm going to go blue line right here. On the blue line, any value of x that finds a y, I can go below that. So that literally means that all of this area here, everything below the line is included, including the line, because it's equal to, right? Equal to the line right there, equal to. And then on the other one, it's y is less than also. It's less than or equal to. So now what are we going to do? We're going to select the marker. We're going to select the orange. And now, again, we're less than. So here we're going to say everything that's in here. All right? Or less than all of that. So what is the area that binds or bounds both of them? Well, I'm going to select red. So everything below the blue, that's also below the yellow. And that is below the blue here, below the yellow here. So all of this is the solution. Everything in red, including the lines, is part of the solution. Now let's do the other one. I'll go back to my pen and select blue. And it says y is greater than, but not equal, greater than x minus 1. Well, if it's greater than x minus 1, when we set x equal to 0 to find the y-intercept, we see the y-intercept is negative 1. So when x is 0, the y-intercept is right here, negative 1. I'm just, like I said, these are all 1, these tick marks. And the slope is a positive 1. So that means you go up 1 to the right 1, right there. Up 1 to the right 1, right there. And so basically, it's kind of like that, the line. Okay? If I hit the dots better, I'd be better off. But, and the other equation is y is less than 3x plus 4. Oh, and what did I do wrong? Let me show you a mistake I made. I got so far ahead of myself. I don't know if I can erase that or not. I got to try and see if I can. Is that an eraser? Yeah, let's try that. Oh, I have to do these over again. So I'm going to draw the line. This has to be a dashed line. Sorry about that. Dashed line. Okay, because it's not including the line. Same thing for this one. This is y is less than 3x plus 4. If we solve for the y-intercept, we set x to 0. We see a plus 4. Plus 4 is our 1, 2, 3, 4. Okay, and our slope is 3. So it goes up 3 and to the right 1, or in our case, it could go, that would be, we're going to go down 3 and to the left 1. Okay, 1, 2, 3, to the left 1. Down 3, 1, 2, 3, to the left 1. Down 3, 1, 2, 3, to the left 1. So if I could draw it, we're going to see that this line somehow comes, dashed line goes through here. Okay? Down 3 to the left 1. Or, in this case, up 3, 1, 2, 3, and to the right 1. See, it's still the same line. But they're dashed, okay? So now, they're kind of close here. Well, let's figure out. The y, for the yellow line, the gold line right here, y is less than the line, the value of the line. So the gold line, y is less than. So that means that we're going to select the marker and select orange. And we're going to say y is, for the orange line, is everything below the line here that is not touching the line. Line not included, dashed line. And for the blue line is y is greater than the line itself. So, but not touching or not including the line. So the blue line, it's everything above the blue line is the solution. So in our case, selecting red to find out what is really included in the solution, the real solution is everything that is below the gold and above the blue. So that is everything within this little tiny sliver here. Okay? Hopefully you see that. If you don't, or you have any problems, don't forget, put a comment below in the video, and I'll see if I can answer it for you.